Hey guys, today's lesson is 7.5 Arithmetic Series. The lesson goals are going to be learning about arithmetic series and different ways to do them for details you can see above. One of the first things we're going to do is define some of the words. So last lesson we talked about a sequence. Sequence is just an ordered set of numbers. And now we're going to have our new word, a series. The series is the sum. So the key word there is the sum. So we're going to add them up. It's the sum of all the terms in a sequence. And so I hope it makes sense then that an arithmetic series is the sum of the terms in an arithmetic sequence. So the only part that makes it different there is we're specifying it's an arithmetic sequence, so we get an arithmetic series. What we're going to be spending time this lesson doing is finding a partial sum. So we're going to find the partial sum, which gets written as S subscript n. That's going to be the sum of the first n terms in the sequence. So for example, Sn is equal to T1, the first term, plus the second term, plus the third term, plus ... all the way up until the nth term. So if we were going to use proper notation to write out the sum of the numbers from 1 to 100, I've done it here. It's typed out already for you. The sum, this means literally the sum of the first 100 terms. So here it's saying it wants the sum of the first 100 terms. And if we were going to write it out, we're going to write out what it starts at. So here's where it starts. And you wouldn't need to know 4, but maybe 3 of them. Then we're also going to show where it ends because it's really important to show where it ends so that we can find out what the last term is going to be equal to in our series. We could, because addition works the same forward or backwards, also write it as 100 plus 99 all the way down to 4, 3, 2, 1, all added together. And to cut to the chase, if you care about where these formulas come from, you can go look at page 449 in your textbook. But the two formulas we're going to be looking at are S of n equals n over 2 bracket 2a plus n minus 1d. That's going to be one way of writing it. We're going to write it this way if we know our first term and our common difference, as well as the number of terms. So that's going to give us our n's. The other way is going to be useful in certain circumstances. So it'd be n over 2 of t1 plus tn, where this is going to be our first term and our last term. First term and our last term. So depending on the question, we might use the first one or we might use the second one. And for each of the 3 questions, we're only doing 3 this time, that we're going to do, I'm going to write out the full equation before we use it. You're going to notice that the version I do is a little bit different than the format in the textbook. I just find it easier this way. But you could use the textbook way or this way. Example 2 says, find the sum of the first 40 terms of the following. So right away, they've told us that we're going to have n equal to 40. So that doesn't tell us if we're going to use the first equation or second equation. They've also told us our first term, or our a, is equal to 3. Maybe it's our t1. We're not sure. We're going to check and see, does it give us our last term? No. So we can't use the shorter equation. We're going to have to use the first equation, this one that I just put 2 stars beside, S of n. We're going to have to use that one, and that means we're going to have to find out the difference. So we can calculate the difference pretty easily just by looking at how much it steps up. So in this case, it steps up by 8, so our difference is going to be 8. That means we're going to be using the formula S of n equals n over 2 bracket 2a plus n minus 1 d. N is 40, so 40 over 2 bracket 2 times 3 plus n, that was 40 again, minus 1 times 8. So all I did here was substitute in for our d that we already had figured out was 8, and the number of terms that was n was 40, and then we also had that our first term was 3. So that would give 20 times 6 plus 39 times 8. And when you use your calculator for that, you're going to get the sum of the first 40 terms is equal to 37,440. And that's going to be our answer. Pretty straightforward. Identify what we have, substitute it into that bigger equation, punch it in the calculator, and solve. For example 3, this time it says we're going to find the sum. So it's going to be S of n of, well, they give us our first term and they give us our last one. So they're giving us T1 and they're giving us Tn. So right away, I know we're going to be using the formula S of n equals n over 2 bracket T1 plus Tn. That's the formula we're going to be using. But we don't know the number of terms. Oh, it even says you will first have to calculate the number of terms. So we're going to have to do that first. And so we're going to do that by figuring out, we know what A is. A is 4. Our difference is, if we take a look, our difference is going up by 11. So our difference is 11. So we can use the formula from the last unit. That was T of n equals A plus n minus 1d. So if I want to find out this last term right here, this term here, T of n, we don't know what it is. That's what we're trying to figure out. But we do know that's going to be T of n. So I can say that 213 equals 4 plus n, that's what we're trying to solve for, minus 1 times 11. So 213 minus 4 is 209 equals n minus 1 times 11. Divide both sides by 11. We get 19 equals n minus 1. So 20 equals n. So we know that we're going to find the sum of the first 20 terms. So that means we're actually going to be finding S of 20. So S of 20 is going to be 20 over 2. Now our first term was 4, plus our last term is 213. And when we punch that in our calculator, so we'll get 4340 over 2, which is 2170. So we'll get the sum of the first 20 terms is 2,170. So that was using the second formula. Example 4 is a word problem. But it's just going to be based on one of those two formulas, finding our A, our D, maybe our N, and putting it in. So let's see. In an amphitheater, seats are arranged in 50 semicircular rows. So this is going to be important. 50 semicircular rows facing a dome stage. The first row contains 23 seats for the first row. And then each row after that is going to be 4 more seats than the previous row. So by looking at this, N is going to be the number of rows. So I've got 50 rows. My first row is going to be A. So that's 23 seats. This part here, each row contains 4 more. So that's the difference. This is an arithmetic series that starts at 23 and goes up by 4 each time. And it wants us to solve for how many seats are in the amphitheater. So that's going to find the total sum, or it's going to ask us for S50. So we're going to use the version of S of n, where it's n over 2, 2a plus n minus 1 times d. So that's going to be n was 50 over 2, bracket 2 times 23 plus 50 minus 1 times 4. So 25 bracket 46 plus 49. 49? 2 times 23. Yep, 49 times 4, sorry. And that whole thing equals 6050. So this was the sum of the first 50 numbers in our sequence. And now we got to go and make sure that we answered what was asked. And in this question, they asked us, how many seats are in the amphitheater? So we can say, therefore, there are 6,550 seats in the amphitheater. So, do the homework, check your answers at the back of the book, and that's it for today.